All right, for division, you need to move on over to page 244 in your textbooks. The word to divide integers with different signs. The quotient of two integers with different signs is negative. This sounds kind of familiar to me. Remember when we just did multiplication, if your two factors had different signs, you got a negative answer. Well, the same thing's true here with division. If you have two numbers in a division problem that have different signs, the dividend and the divisor, and they don't have the same signs, then you're going to get a negative answer. So whether the dividend, like 33, is positive and the divisor, negative 11, is negative, that's going to give you a negative answer, but the reverse is true as well. If the dividend, negative 64, is negative, but the divisor, positive 8, is positive, you're still going to get a negative answer. So it doesn't matter which one's positive and which one's negative. Different signs mean a negative answer. So the only thing you need to really worry about, though, that you could get into some trouble is that if your divisor is 0. When the divisor is 0, you actually can't do that. How can you take a number of things and put it into 0 groups? Think about it that way. Say you have, 12 things. You have to divide that up somehow. You can't put it into 0 groups. It's not possible. So that would be an impossibility. Let's take a look at the examples. So again, this is on page 244, number 1. Again, all you really need to write is 244, example 1. Write the problem. Dividend 80 divided by divisor negative 10. 80 divided by 10, you could just mark off zeros and you would get 8, but because one's positive and one's negative, the answer is negative. Example number 2. Oh, they're writing it a little bit differently. In division problems where we write it like a fraction, the top number is the dividend and the bottom number is the divisor. So you have negative 55 over 11, or negative 55 divided by 11. Again, one negative and one positive is going to give you a negative answer. And in this case, it's negative 5 because 55 divided by 11 is 5. So negative 55 divided by 11 would be negative 55. Example 3 says, use the table to find the constant rate of change in centimeters per hour. Now, had we had chapter 1, we would understand what they mean by finding a constant rate of change. But it's not really that difficult to understand. If you look over here at this table, as the time goes up by 1 hour, so from 1 o'clock to 2 o'clock an hour, from 2 o'clock to 3 o'clock an hour, from 3 o'clock to 4 o'clock an hour. So as the time goes up by hours, the height of the candle seems to be going down. So it was 10 centimeters, it's now 8 centimeters. That's a deduction of 2, then 6 centimeters, then 4 centimeters. So it's going down by 2. If I want to find the rate of change, I'm going to take the change in its height, we'll call that y, and put it over top of the change in time, we'll call that x. So I would actually make a division problem of negative 2 divided by 1. So for example 3, you would just want to write negative 2 divided by 1. That's the change in height over the change in time. Because they're different signs, I get a negative answer, and 2 divided by 1 is 2. So the constant rate of change is negative 2 centimeters per hour. Negative 2 centimeters per hour. And we'll learn more about rate of change later in the year when we go back and do chapter 1. But what I want you to do right now is to pause the recording and go ahead and do problems A, B, and C. All right, let's take a look at page 245 now. The quotient of two integers with the same sign is positive. That sounds like multiplication as well. When you have two numbers being divided that are both positive, the result is a positive answer. The same is true for two negatives. And again, like with multiplication, this is where students get in trouble. They see these negatives and they think the answer has to be negative. But with division, two negatives actually equal a positive. So it doesn't matter if it is the both positive and you divide and you get a positive answer, or if they're both negative, you divide, you get a positive answer. So let's look at examples 4, 5, and 6. Example 6, and this is page 245, by the way. Example 6 says negative 14 divided by negative 7. And again, because they have the same signs, we're just going to kind of ignore those negatives, and it's just going to be like 14 divided by 7, which is positive 2. Example 5, negative 27 on top, that's the dividend, divided by negative 3. And again, negatives, if they're both negative, you're going to end up with a positive answer. So the answer here is positive 9, because 27 divided by 3 is 9. And then they're going to throw a little bit of algebra at you. So we would want to write the negative 16 divided by x. This is example 6. And then x, I'm going to put a little semicolon here. X equals negative 4. So I'm going to take negative 16 and divide it by negative 4. They're both negative, so my answer is going to end up positive. So I ended up with a positive 4. So why don't you try D, E, F, and G?